port where Columbus will be attached. This will allow for camera views to be available to the robotic operators. He'll then continue down into the payload bay and set up for his work there, installing a few bags and pre-positioning some hardware so that he has a nice staging area to work from. EV2 will also be translating to the payload bay, but he will perform this translation along the port side of the space station, again along the lab in Node 2. He will stop to pick up a foot restraint, which he will later install in the arm off of the station's arm so that he can use that as a work platform for his work. One of the first tasks that EV1 will be doing when he's at the work site is to demate a power cable from the Columbus module that powers the heaters during ascent. That cable will be disconnected and stowed on a carrier panel on the side of the orbiter. Meanwhile, EV2 will be working with the arm operator to bring the arm down into position to install a foot restraint, and then he'll ingress that foot restraint, and GCA, or ground control, assist the arm operator into position to remove a grapple fixture from the sidewall of the orbiter for later installation onto Columbus. While that work is in play, EV1 will begin some preparatory tasks on the Columbus module to get it ready to receive the new grapple fixture. We'll start by removing one of two shields that will be required to be removed. The first one shown there highlighted. And then momentarily EV2 will come along with the grapple fixture and attach it with 4 expandable diameter fasteners. Now, the reason why we have to install the grapple fixture is because of clearance concerns with the OBSS, or boom, that was launched in the payload bay. So once that's installed, the 2 crew members will work together to then remove a second shield so that we can attach some electrical cables underneath. This video here is taken from our NBL, or Neutral Buoyancy Laboratory facility, where we do most of our training. You can see the panel's rather large. They work together to stow that out of the way. And then they attach the 2 electrical connectors that provide power from the arm into the Columbus module to power the heaters during the transition to the payload bay. The 2 shields will then be reinstalled, and the crew members will clean up from that work site. The last task that has to be performed to prepare the Columbus module for berthing is the removal of 8 CBM, or Common Berthing Mechanism, seal covers that protect the seals from debris during launch. Those covers are shown here in the video. They're basically crescent-shaped hard shells that we'll stow in 2 trash bags and take back to the airlock. Meanwhile, EV2 will be coming off the arm and removing the foot restraint so the arm can later grapple the Columbus module. Both crew members will translate back to the airlock to change out some hardware and then continue on to the P1 truss area, where they will set up some hardware on the CETA cart, or translation cart, in preparation for stowing a nitrogen tank on the following EVA. We will be installing 2 clamps there, and then we'll be releasing a few bolts on the nitrogen tank assembly and demating the electrical connectors. EV2 will translate to the back side of the truss segment to open up a shroud and demate 2 flex lines that connect the nitrogen tank to the ammonia system for pressurization. And then, if time is still available at the end of the EVA, we will be transferring a new piece of hardware out to the outside of station. It's a temporary stowage device that is essentially a bracket that we can attach to large components to aid in stowing that hardware during change-out operations.